Hi, today I'm going to show you how to set up your own PGBC instance running on Google Cloud. This is developer instance, won't cost you a penny. It's on an E2 small, which means it's only 2 CPUs and 2 gigabytes of RAM, but that's plenty big enough to do development and testing purposes on. So let's start straight away. The first thing we need to do is to go to dropblockonline/PGBC developer. Don't worry if you can't remember the address, it will be posted just below as a nice little bit.ly job. Now, in here, what you need to do is to put in a username and password. Now, this password is not going to be used for PGBC, but you can use it for your own instance of Dropblock, which also comes on this machine. So, press sign up, agree to the fair use policy, and the system will then go away and create your new Debian and Kensei virtual machine, place PGBC and Dropblock on there, and also initialize Boudica, our AI engine and agents that can go out and connect to Google Gemini. More on that in our Discord channel and other videos. So this takes about 2 minutes to do, not too long, as it does go out and actually create these virtual machines. So this virtual machine is your instance, and nobody else has access to this machine. People at OmniIndex cannot access this machine. That's very important to know. Also, if the machine is idle for 21 days, it will automatically be destroyed, taking with it all your data. If you know you're not going to be able to use it for 21 days and still want to keep your data, please just inform OmniIndex via Discord and we'll make sure it doesn't get into the cycle. Okay, so that's all done, and I'm now able to log into my Dropblock instance. Here, it gives you basically starting information, but most importantly is this piece at the bottom. It's your machine address, the port number, the PGBC Postgres, and PGBC is a port of Postgres, the Postgres super user, and the password. The password is the same for all instances, so please make sure you change that. So I'm just going to go and paste that over here. I will copy the address. Okay, the first thing I'm going to do is just put the address in up here. This is now your own instance of Dropblock. Same username and password you used a minute ago will be able to let you access this and go and put all the various bits and pieces in it. You also have the API in here. Okay, but I'm not going to do that. What I'm going to do, pardon me, is minimize that. Bring up my screen here, and also I can bring up PG admin. I prefer a PSQL. It's whichever tool you want. So all I need to do here is log into the new instance. PSQL -u is the Postgres user. -h is the address. -p is the port number. And press enter. And then put in the initial password, Postgres BC. So if I do a quick DN on here, this just lists what's on the system as standard. And you can go and have a look in all these, go and change some of them. Be careful because it is the Postgres PGBC, although most of it is standalone, logging the analytics. It's all standalone. It just gives you a bit more information about what's happening on your system. So the first thing I really need to do is go and change my password. There we go. So that's altered the role of there. The super user role can't actually do very much with chains and blocks. Remember, this is a Web3 system. It can do anything you like with standard tables and standard schemas. It can read them all, it can do everything. But actually, that's not the point of PGBC. The point of PGBC is to make your data incredibly secure. And that means there's zero trust on each piece of data. Zero trust means that a super user cannot read it. So let's just create a new role. We're going to give this role login access. That's all we need to give to it. As you can see here, if you wish to utilize smart contracts, you'll now need to create a block if it doesn't exist already. I'll come on to blocks and chains in a second. So now that role's been created, I'm going to give it a password. Auto role Simon with password Simon, nice and secure. Okay, role has been altered. So if I now come out of that, come into this with Simon, and minus D, Postgres, D for database, and Simon. Okay, I'm now inside the database. Now, as I said, it's not your standard Postgres, which means that I don't have to give the roles and everything else you would normally have to do. However, this is a very limited role. So if I do DN like I did before, it's not going to allow me. It's just not there. I can create a schema, maybe. Create schema, Simon. No, I can't. Permission is denied for me to use that database. What I can do is create chain, Simon. So chain is a very special schema. It puts into place the ability for the encryption, but most importantly, it puts into place Boudica, the AI engine, which can be used across all your data. Now, inside that chain, I can do various bits and pieces. I can create a standard table. So create Simon T, and in there I'll put fname text, lname text. Doesn't help if I don't put the right thing in there, does it? Create table. Okay, so that table has been created, and I can insert data into that table. There we go. Okay, so I've added one row into that table. Tables are great, but they're not very secure, so the super user can go and read everything inside a standard database table, which makes it incredibly insecure, especially if you want to hold credit card details or zip codes or social security numbers. So instead of creating a table, we would also always suggest you do this. Create block. Okay, and in this block, I'm going to put fname encrypt, and that's standard text, lname encrypt. Again, standard text. So now I've used the word encrypt, appended it to the field name. And what that means is that every time data goes into that area, it will be encrypted automatically. Because I've used the term block, it's also mutable, which means it cannot be deleted or updated. If it's updated, a new block is created every time. Now in this instance, you only have one node running. Generally speaking, with PGBC, you'd have more than one node. Each one has its own encryption algorithm. Each field gets encrypted separately, which means if one of your databases gets attacked, the rest are all there and you haven't lost any data because it is distributed. It's a Web3 distributed system. Okay, create that. Now let's go and insert some data into both of these. So insert into Simon T, and again, same data. Okay, again, we just come back and got one. So now it's just a very simple select star from. Two rows, two fields, Simon Bain, Simon Bain. Let's go and change that to B. A lot more data. You can see we have the AIs. Again, if you go to our Discord channel on that, we have modified dates, we have ID, prior hash. It's a Web3 system. Its hash is the first one. Here you can see the name, Simon Bain. It's plain text. I said it was encrypted. That's because you've done the query on it. Anybody else would not get that in plain text unless you've given them insert and select roles on this block. You cannot give a super user insert and select. It has to be a standard user. If you give a standard user insert, they'll be able to insert data, but not be able to read it. If you give them select, they'll be able to select and search data, but they still won't be able to read it. And that's for analytics purposes, for doing standard things like counts and the like. So if I come out of this, I can also search on that data, even though it's encrypted. So if I do a where, special search, we have to surround it with a tilde, simon.simonb.f, name encrypt, like, SIM. Even though it's encrypted, we can do a partial search. We can do a like search. It's full text search, even on encrypted data. It's homomorphic encryption. Really important to remember that. You do not lose any access to your data just because it's encrypted. Okay, and there's my role there. Okay, now I'm going to come out of that and come out of that entirely and go back in as Postgres user, which is my new password. Press enter. And I'm going to do exactly the same queries again. The first one I'm going to do is select star from Simon, table. There's my two rows. Now, if I do select star from Simon B, there's no plain data here that was meant to be encrypted. We do have the genesis, we have the ID, we have the date. Up here we have fname searchable, fname underscore PGBC, lname searchable, lname underscore PGBC. And as you can see, the data in there is completely different. And that's because this user does not have access rights to that data. Now, as a super user, we don't want to stop them accessing the block or the table, because the idea of a database administrator is that they can go and administer the database. That does not mean they should have the rights to administer the data. Okay? So here at OmniIndex, we believe that the data should be zero trust, and that's all data. So we start from the point of zero trust data, which means the super user does not have access, and only the owner has access to the data, and only the owner can change access rights to the data. So there you have it. Now, I've used PSSQL. You could just as easily use any of your other tools, Postgres tools. Say PGBC is a port of Postgres. So here we have a PGadmin. So if I go to register a new server, do that, connection, hostname, that, username, password, my new password, to 35, password, and now go out and access it. So now I have there my databases here, my schemas. If you don't know Postgres schema is similar to a database with inside SQL Server. My analytics tables, the OmniIndex PGBC, and here's my Simon schema. Inside my Simon schema, I've got two tables that I created. Now, Simon B is a special table. It's our block. In here, we have all of the bits of the block. And you'll see here, these are our AI tables. This is to do with the schema, being that it is a chain, not a standard schema. So we have all of our normal ones. But also, as you can see, we can mix and put standard tables in here as well, which some of these are. So there you have it. There's how you create your first instance inside PGBC. It's a developer instance. It runs on E2 small, which is 2 gigabytes of RAM, 2 virtual CPUs, and you get about 6 gig of free space. It is a free instance, yours forever free. Do not use it, please, for big payloads. We won't be able to because of the size. What we would ask, though, is that you send us any of your use cases. Tell us what you're using it for. We're always interested to hear what people are using our systems for. So, thank you for your time. Have a great play.